This chapter is not near as long as the last chapter was, so we're going to focus on a couple of key concepts here. Typically, I give you those key definitions in the slides. I'm not going to do that on this one because some of these definitions, as we look at them, you don't want to look at them just by the word definition. You want to have a picture associated with it, or maybe a YouTube that'll help you with that. So what I want you to do when you enter into this chapter or in this session, I want you to go to that front of the chapter, and we're dealing with chapter 11 in our book, and I want you to kind of read down through those different definitions. So that first glossary is going to be a really handy tool for you. We're also going to look at some of those same concepts that we looked under the physics section or session, and we're going to kind of expand that and look at these chemical difference pieces here. As you go into the book, you're going to see that this chapter is much shorter. We're not going to look at different laws. We're not going to look at some of those different pieces. But there's some things I do want you to kind of look at. When you go in and talk about homogeneous versus heterogeneous, I've given you a flow chart later on in the slides here that kind of breaks down the difference between mixtures and compounds and heterogeneous and homogeneous. Homogeneous means it's going to be uniform throughout. Heterogeneous means it's going to be a mixture of things. So you can think of it a couple of different ways. I can think of something being heterogeneous, like concrete, for example. It's going to have rocks, it's going to have some chemicals in it, we're going to have some fine particles, we're going to have a mixture of different pieces. You can kind of think of it like a fruit cake. You know, if each cut of my fruit cake, I'm going to get something that's a little bit different. But if I do something that's homogeneous, for example, a dissolved solution, any little piece of that solution, if I take out a teaspoon of it, it's going to look like another teaspoon of someplace else in that solution. So heterogeneous versus homogeneous. Later on in the chapter, it's going to discuss, and I'm having some thoughts about how to put it into the PowerPoint for you, to talk about pH and the pH scale. We know about pH, and it kind of relates back to how an atom can, or how a compound can give up a proton, or how it can give up a hydrogen atom, and we talk about the percent hydrogen, hence the term pH. But we know more about it in terms of acids and bases. My acid has a low pH, meaning it's going to have a pH of around 2 or 3. And those are going to be things like vinegar, hydrochloric acid, acidic compounds like citric acid. Those are our acids. And then when we talk about bases, those are something else entirely, that we get a basic material like bleach, for example, would be basic, or sodium hydroxide is another base. And it's going to have a high pH. The pH is going to be around 10 or 11. So later on in these PowerPoints, I'm going to give you a pH scale that looks at acids and bases. I'm going to show you the different ranges of acids and bases, but for the point of our chapter here, what we want to know from a safety aspect is if something's very acidic, it's going to be corrosive. So we get into that definition of what's corrosive. I can have something that's very acidic and it be corrosive. I can have something that's very basic and it can be corrosive. But when I deal with acids and bases, they can cause harm. So I want to make sure that people are looking at those acids and bases. And when I react acids and bases, I'm going to have potentially some violent reactions. So I need to make sure I understand what's happening there. So later on in the slides, you'll get a bit of that. Couple other pieces, we're going to talk about chemical reactions. Well, chemical reactions, you kind of have a feel for that. If I leave a nail out, and that nail is made of iron, it's going to react with the atmosphere. It's going to take the oxygen out of the atmosphere, and I'm going to generate rust. I can also do mixtures, and I'll show you a picture of a mixture of an Epsom salt solution mixed with a solution of washing soda, where I take that Epsom salt, which has got a salt compound, and it goes into its ions into the water, and then that will react with the ions from the other compound to produce a new compound that solidifies or precipitates out. So I get a chemical reaction that way. We know we all have a lot of chemical reactions we're familiar with. Striking a match is a chemical reaction because fire is a chemical reaction. It's a reaction with the fuel and oxygen, and it's going to combust, and I'm going to generate the products of that reaction are carbon dioxide and water. So we inherently have an idea of what a chemical reaction is. So I want to make sure that we talk about that. But then we have another thing. When we're in the process industries and we're doing transformation, or we're doing some of those configuration changes that we talked about early on, What we want to look at is things like catalyst reactions. The catalyst is something that is going to promote a specific type of reaction. It neither and it's not used up in the reaction. So I can put a catalyst in and it can either make the reaction happen faster, or it can actually cause the reaction, or it can selectively produce that reaction. So in the process industries, we deal with a lot of catalysis. I make polymers using catalysts. I change from a straight chain carbon or straight chains to cyclic changes using catalysts. So in the refining industry, we use a lot of catalysts. So I encourage you to look at that portion of the chapter about catalysts. So some key things that we want to look at. You've got those key points right there at the beginning. So as you read the chapter, I want you to look at those definitions, look at those pieces. I want you to read over the glossary. And hopefully this PowerPoint will help you with a few of the other concepts that aren't as straightforward. When we talk about atoms, molecules, and the periodic table, I've given you a couple of links to a couple of YouTubes. One is a Bill Nye the Science Guy one, and hopefully that will help you out as well. But if you have any questions, feel free to holler. But this chapter really is just to get you to familiarize the fact that when I'm dealing in the process industries, I'm going to have to deal with chemistry. And I'm going to have to really understand the chemistry that I'm running into. And I have to understand the hazards associated with that chemistry. So hopefully this chapter will give you a good handle. Hopefully this video and those PowerPoints will help you out as well. And the homework will help you focus on what's going to be what you're going to need to know going forward. Good luck.